Welcome to Spaceverse, your portal to cosmic adventures. How old is the universe? It's wild to think that just 90 years ago we had no clue about most of the universe. Back then, astronomers believed that the Milky Way was all there was, that every star in existence was packed into our galaxy. But in 1917, astronomer Heber Curtis noticed something unusual, a sudden bright flash inside what was then called the Andromeda Nebula. This was a nova, a star that briefly shines intensely before fading away. Intrigued, Curtis dug through old telescope photos and found 11 more novas in Andromeda. But something didn't add up. These novas were way dimmer than the ones in the Milky Way. That difference led him to a groundbreaking conclusion. Andromeda wasn't just a nearby cloud of gas, it was a separate galaxy, and it was incredibly far away, around 500,000 light-years. Curtis became a strong advocate for the island universes theory, which proposed that the universe wasn't just our Milky Way, it was filled with countless galaxies, each its own vast star system. This discovery changed everything. It set the stage for one of the biggest questions in science. Just how big and old is the universe? This was a game-changing moment for both humanity and our understanding of the cosmos. But despite this breakthrough, scientists still believe the universe was static, so much so that even Albert Einstein tweaked his equations, adding a cosmological constant to force the universe to stay still. Fast forward to 1928, and Edwin Hubble shattered that idea. By measuring the movement of distant galaxies, he discovered that the universe wasn't standing still, it was expanding. This meant that the universe had a beginning, and by tracing this expansion backward in time, we could estimate its age. At first, Hubble's calculations suggested the universe was just 2 billion years old, way off from what we now know. Then, in 1965, the discovery of the cosmic microwave background radiation sealed the deal. The universe was definitely expanding. But one big mystery remained: how fast? Over the next few decades, scientists fiercely debated the universe's expansion rate, with estimates swinging wildly between 8 billion and 18 billion years. Things got even trickier when astronomers studied the oldest known stars and found some were older than 8 billion years. But wait, how could stars be older than the universe itself? This paradox was a major roadblock in cosmology, forcing scientists to rethink their calculations and refine our understanding of the universe's true age. Then came the Hubble Space Telescope, and in 1997, it delivered a groundbreaking revelation. The universe isn't just expanding, it's accelerating. The culprit? A mysterious, unseen force that scientists dubbed dark energy. Once dark energy was factored into our calculations, astronomers arrived at a solid estimate for the universe's age: 13.8 billion years. Mystery solved, right? Well, not quite. There's still a big problem. The Hubble constant, which measures the universe's expansion rate, remains a hot topic of debate. Based on fundamental physics and the cosmic microwave background, scientists predict it should be around 68 kilometers/second per megaparsec. But when astronomers measure actual stars and galaxies nearby, the numbers don't match up. This discrepancy has left us wondering: could our understanding of the universe's age be incomplete? Now, brace yourself for something even more shocking. A group of ancient stars in the Milky Way might be as old as the universe itself, or even older. Meet M92, a dense, spherical cluster of stars about 27,000 light-years away. Its newly refined age estimate: 13.8 billion years, the same as the universe. This discovery could shake up our current estimate of the universe's age and even help resolve long-standing cosmic mysteries about its evolution. The age is right on the edge of what other studies have estimated, said astronomer Martin Ying of Dartmouth College. It helps us establish a lower limit for the universe's age. After all, we don't expect a star cluster to form before the universe, right? Globular clusters like M92 are tightly packed groups of stars that likely formed around the same time, making them ideal for age determination. Since stars evolve differently based on their initial mass, larger stars burn out quickly, while smaller ones live much longer. Astronomers can estimate a cluster's age by studying how many of its stars have moved past their fuel burning phase. Traditionally, these age estimates rely on assumptions about stellar evolution, which can introduce uncertainty. To get a more precise result, Ying and his team took a different approach. They used a computer to generate 20,000 synthetic versions of M92, each with a different possible age. Then they compared these models to real observations from the Hubble Space Telescope, looking for the best match in terms of color and brightness. While scientists have measured M92's age before, previous estimates relied on just a single synthetic star model. By comparing thousands of simulated star populations, the researchers drastically cut down the uncertainty in their calculations. This innovative technique, which accounts for the assumptions baked into each model, reduced the uncertainty of M92's age by 50%. The team's final estimate? 13.8 billion years, give or take 750 million years. What's truly remarkable is that this aligns closely with the most widely accepted age of the universe, a little over 13.8 billion years, with a much tighter error margin of just 24 million years. But here's where things get interesting. If we take the so-called Hubble tension seriously, the ongoing debate about the universe's actual expansion rate, then we might have to admit, we don't know the universe's age as well as we thought. This new finding also shines a spotlight on a recent University of Ottawa study which proposes something radical. The universe might not be 13.8 billion years old at all, but a staggering 26.7 billion years old. At the heart of this debate are two major cosmic puzzles. First, we have ancient stars like Methuselah, which appear to be older than the universe itself. Second, the James Webb Space Telescope has spotted surprisingly mature galaxies just 300 million years after the Big Bang, galaxies that by all logic should have taken billions of years to form. With advances in computing power, theoretical models, and precision measurements of star clusters like M92, along with discoveries of ancient galaxies from the cosmic dark ages, we're faced with a big question. Is the universe actually older than 13.8 billion years? Do we need a completely new approach to cosmology? Renowned physicist Michio Kaku hinted at this possibility a year ago, but if the universe turns out to be older than we thought, even his estimates may need tweaking. Professor Kaku, your books, The Equation, Physics of the Future of Humanity, all work with the idea that the universe is around 13 billion years old. But what if that's wrong? That's the issue at hand. The James Webb Space Telescope is shaking up everything we thought we knew. Suddenly, it seems like we might need to rewrite all our textbooks about the early universe. Here's why. Creating a galaxy like the Milky Way with its 100 billion stars takes billions of years of cosmic evolution. But JWST has found 6 galaxies that formed just 500 million years after the Big Bang, and they're up to 10 times bigger than the Milky Way. That shouldn't be possible. There shouldn't be massive, fully formed galaxies so soon after the Big Bang. Something isn't adding up. We may need to revise our entire theory of how the universe began. And that's it. The universe is full of mysteries, and the deeper we look, the more questions arise. Is it truly 13.8 billion years old, or have we been underestimating cosmic time itself? With new discoveries from JWST and cutting-edge research, we may be on the brink of rewriting the story of our universe. Stay curious and keep exploring, because in Spaceverse, the journey never ends,